Thank you for joining us. Good morning. If you're in the West Coast, it's nice and early today, and it's a nice day today. The rain has stopped. Good afternoon, folks. Those joining us from other parts of the world. We'll start in about one more minute, just to give people a few extra minutes to join us. And today we'll be talking about managed residential Wi-Fi services. Some of the topics today we'll talk about is some of the things that we are hearing, talking to you, your service providers, our customers, about the challenges that you face in delivering managed Wi-Fi services. We'll be talking about that for a little bit and explaining some of the problems that we see as our customers' usage patterns change, right? The types of devices that they use, how they use those devices. We'll talk about that a bit today. We'll also have a real world example. I'll tell you something, I'll show you something that happened to me about 2 months ago, and a support call that I was on. I helped out a man with some issues, and I'll show you some of the things that you probably will recognize it, because I'm quite certain that you have seen what I saw many more times than I've seen it. And so I'll share with you what we did to solve his problems. And then finally, we'll talk a little bit about what Cambium is going to be doing in 2021 to deliver managed residential Wi-Fi services and understanding, again, the usage patterns, the device type patterns that people have today typically. So with that little short introduction, it's now, my phone says 7:02, so I think it's time for us to get started. And anyone else who's going to join a few minutes late, well, they'll just have to skip the introduction, won't they? So my name is Darren Hermans. I'm a product manager at Cambium Networks. I work in the enterprise Wi-Fi and residential Wi-Fi business unit, and I manage the portfolio of access points and products. My background, I worked at a startup company really focusing on DSL technology, starting January 2000, and I was there for many years developing DSL-based solutions. So lots of experience in that portion of the broadband. I was at Motorola from 2007 onwards, and that's where and actually before 2007 I got into Wi-Fi, but really 2007 is when I started to manage a Wi-Fi portfolio and develop my own Wi-Fi access points in 2007. So I've been doing Wi-Fi for a long time, and at Cambium Networks doing kind of the same thing and bringing that experience to help service providers in enterprise business as well as residential. All right, so there we go. So how things have changed. Again, I'm not going to be telling you anything here that you don't already know. In fact, you could probably do this presentation better than I can. Because this is stuff that you guys live with every single day. And the way things used to be, well, let me see, I think I just, all right, there we go. The way things used to be is we used to deliver bandwidth to the home, right? So back in the days when I was doing DSL technology, we were delivering broadband to the home, not inside the home. And what happened inside the home was really up to the individual person, wasn't it? The service provider would deliver the bandwidth, either fixed wireless broadband, fiber, DSL, DOCSIS technology. And the option of what happens inside that house was really up to the residential subscribers, up to them. They could buy something off the shelf. In later years, service providers would offer a home router, a home Wi-Fi router that they could lease to the subscriber and make a little bit extra money on leasing this technology, or even just selling it to them outright. But basically what happened inside the home stayed inside the home, didn't it? It's kind of like Las Vegas. But the way things are happening now is that that's no longer satisfactory, because Wi-Fi is critical. It is the mission critical portion of the network. And today with the COVID-19 work restrictions, many people are realizing that they can work from home. They can conduct their business. Their kids can go to school. Now it's not ideal. And my son, I have a 13-year-old son, and he needs to go back to school, I think. But for the time being, he is at home and he's doing his school from home, and he's doing it effectively. And so people are understanding that they can do these things. And when they begin to realize what else they can do at home and from home, their expectations go up, and their expectations of you and the service that you deliver also goes up. So you deliver service today, the broadband portion of that link is pretty solid. It's well engineered. You've engineered that solution. You've done your testing. You've used CN Heat from Cambium networks to determine the optimal location of the antennas. You've done a lot of work to ensure that that broadband portion is solid, it's professionally installed, and you have high performance and high speed. Once you get inside the home, you do lose quite a bit, right? Because the inside of the home has different characteristics, construction, different types of reflective and absorptive type materials, unknown devices. You don't know really what's in there. You don't know. I have a printer, a wireless printer that's probably 12 years old, probably 2009. I bought that thing, and you know, I still have it. Don't use it very much, but it's still there. And this is the expectation people have in their homes. They tend to keep that old stuff around, keep it connected, and then they connect new stuff, right? New stuff. So you have your Wi-Fi based light switches, thermostats, doorbells, all sorts of different things. And so you have lots. So once you get inside the home and you realize you have to deliver bandwidth through the home, the expectation on you goes up quite a bit. So let's walk through some of these examples here. So what is the laptop's Wi-Fi experience in this little drawing? You have an access point, pretty good. It's 11 AC, it's, fairly new. 5 gigahertz, that's a good band. Always be on the 5 gig as much as you possibly can. 40 megahertz channel, so it's not, it's good. Not a whole lot of interference from the neighbors with a 40 gig channel, 40 megahertz channel. 2x2 client, what's your performance? Well, it's probably going to be about 280 megabits per second. That's about what it's going to be in that scenario right there. And that's going to be really good because you have a 50 megabit broadband service, lots of bandwidth to the laptop. Experience is good. So now what happens when that device moves within the home? What happens is the signal to noise ratio, the SNR drops. As the distance increases, that lowers the MCS rate. Now you've dropped 1 or 2 or 3 MCS rates, and now you're using a lower modulation schema. And so your efficiency also drops. Efficiency as a measure of how many packets we can transmit to that laptop. And now that drops as well, and with it, the speed drops. But things are still pretty good, 135 megabits approximately, and we're still in good shape, no problem there. Nice thing about Wi-Fi, it's designed to do this, right? Wi-Fi is designed to maintain that good quality link, even as distance increases, by lowering those modulation rates to maintain the quality. So Wi-Fi is very good at handling this situation, no problem. But if you're like me, it's not just a laptop in a home. Now you've got more devices, and they're all doing things. Now in my house, I do these kinds of webinars. I'm on Microsoft Teams, and I use Zoom as video conferencing tools. I use them all day long. Big portion of my day is spent doing video conferencing, and my son, exactly the same thing. He does video conferencing constantly for about 5 hours a day in school. So he's in the 8th grade, middle school. 5 hours a day, he's doing video conferencing almost solid. He does have some breaks. He gets to shut it off from time to time. So there's other things going on inside that house. There's other devices, and now what happens? We have a new problem: latency. As that access point now has to transmit packets to my laptop, it also has to transmit packets to other devices, other laptops in the house, desktop computers. There's a big Mac right here, I can see right here behind me. Lots of other devices inside the house that are going to be using bandwidth. It has to transmit to each and every one of them. Wi-Fi is half duplex. It cannot transmit to all devices or even multiple devices at the same time. It doesn't do it. We also often talk about 11 AC multi-user MIMO. Well, the problem is very few clients. actually support multi-user MIMO 11AC. So that really is effectively not a solution for us. It doesn't really affect us at all. Packet latency is the big killer here, because as packet latency increases, things that are latency sensitive, like video conferencing, audio phone calls, are affected dramatically. If you're just streaming video, you don't even notice the packet latency. You'll never even notice it. Extra 100 milliseconds, you wouldn't even notice it. Streaming Netflix, something like that. But if you're on a video call, you will see packet latency. But now see, our bandwidth has dropped approximately 18 megabits per second. We're now below our broadband service, and we've introduced a new problem, packet latency. Now, how does your house look? Does it look like this? A lot of your clients do. You realize in the United States, I believe it was March 2019, the spring of 2019, that I read an article that the average home had 12 devices in an average home. That was a year and a half ago, before the COVID-19. And certainly with COVID and other changes, those numbers are up dramatically. Now we're expecting about 20 devices per home. Lots of different devices consuming bandwidth. One of the things that's going to be consuming tons of bandwidth inside these homes is streaming audio. So you get your Apple HomePod, Alexa, Amazon Alexa, Google Home. These technologies, Sonos, Bose audio systems, these systems allow you to put a smart speaker in 2, 3, 4 rooms of the house, link them all together in a home group so that you're streaming audio to each and every one of them. And guess what that audio is being streaming over? Your Wi-Fi network, right? Your Wi-Fi network is now being asked to do much, much more. Now in this scenario, I'm dividing by 12. I could very easily be divisible by 20, and this slide would still be valid, but our bandwidth now has dropped significantly. The increase in latency is now a big, big problem. If latency should increase in these types of scenarios with this type of density, latency can increase by about 20 milliseconds would not be uncommon. I'll show you that next. So let's say I'm working bottom up. Looks like I've kind of got myself a little bit out of sequence. That's okay. Let's start at the latency and work our way up to the top. Latency can increase by 20 milliseconds easily with 12, 13, 14, 15 devices in the network, 20 devices. And once you start to add that latency on top of normal latency that's normally experienced in the application, you can get a really bad experience. So here's a typical Zoom. I like Zoom for this because Zoom actually has statistics. If your Zoom client, you click under video settings, you look at the settings box, dialog box, there's an option that says statistics. If you click on that, it will tell you what that latency is. That's where I got that screenshot right there. I did this myself in my house. I cleaned everything up. I turned off a bunch of devices. So I only had a few things going, plus my laptop. And I started the Zoom call, and it was a good call. Everything was fine. The quality was very nice. And then I snapshot this picture right here. So you see my latency was 74 milliseconds. I was transmitting 74 to 79 milliseconds on the receive side. So it was good. The jitter wasn't bad. 7 milliseconds of jitter. Zoom actually recommends that your latency be less than 125. Less than 125. I would suggest to you that Zoom is really good at controlling latency. They do it by reducing your resolution and reducing your frames per second. Reducing the resolution and the frames per second to extend your latency boundary. 125 milliseconds is a lot. Typically, without those extra tricks that Zoom is doing, those frames per second and resolution changes, your latency should be 100 milliseconds. That should be the threshold. So let's just say it's 100 milliseconds, because I think that's the better number. Something I like to design the network to is 100 milliseconds latency. We're right there. If I add 20 milliseconds to 74, I'm at 94 milliseconds with a jitter of 7. I'm right at the 100 mark. I'm right there already. So what does that mean? It means I have plenty of bandwidth. Broadband coming to the home is fine. I have lots of broadband coming to the home, and I have a good Wi-Fi signal inside the house, but I have latency. which decreases the experience and means you're going to get trouble ticket calls where people say the experience is bad, and you're not going to know why. But this is the reason. Another common reason, Wi-Fi coverage gaps. This is the size of the home, the wall construction, reflective surfaces. Bathrooms are often covered in tile, large mirrors. The type of construction material, which is reflective or absorptive material, can cause Wi-Fi coverage gaps. The location of the AP is not always ideal. Oftentimes the APs are located at the minimum point of entry, the MPOE. We used to use that term back in the DSL days, MPOE. And that's the minimum point of entry into the house. That's the point at which the broadband comes into the house. Usually the Wi-Fi AP is located in that area. That may not be the optimal location. Congestion. This is a tricky area. These days, we all use dual band Wi-Fi access points, 2.4 gigahertz and 5 gigahertz. Well, the clients will more often prefer 2.4 than you realize. They will. Apple iOS devices will prefer 2.4 gigahertz when the RSSI threshold is -65 dBm. That's on their websites, on the support site. That was actually released several years ago, an iOS update. -65 is a pretty strong signal, and that's where it starts to prefer 2.4 gigahertz. I should have said here, we'll prefer 2.4, yeah, when the signal is -65. So if your 5 gigahertz radio is -68, it'll still prefer the 2.4 gig. 5 gig has less range, but fortunately more capacity. So congestion can be a problem. So one of the common solutions is mesh nodes and repeaters. So that's a common solution. And you can do that with Cambium's R195 series. It can act as a mesh repeater in this type of scenario. So what about the location? And this is based on a real world example right here as well. Back in March, when our COVID-19 shutdown started, a friend of mine called me and said, hey, I just bought this new mesh system for my house, and it's terrible. The performance is awful. I told him, yes, what's happening? He said, well, I can bring up a web page, but then it'll time out. It'll get a web page timeout, and I have to refresh, then it'll come back up. Then it'll time out again, it'll come back up. And he told me, on my laptop, it says that I have 800 megabit per second link. I got lots and lots of signal. I've got 4 bars. Well, the problem is he did this right here. He put the mesh access point in his office, second floor, far corner of the house, right next to his laptop. So he had a strong link to the AP, but not over the mesh. So that was the wrong location. That was a bad experience. So what if we just add another mesh? Well, the problem there is you're adding to the noise floor. We're just adding to the noise floor. So always really understand what benefit you're going to get out of it. And quite frankly, for my friend who had this problem, I had him move the mesh repeater in his house to about 50%. About 50% of the way into the house, not all the way in his office where his laptop was. And this is how we optimized it for him. And this gave him a nice solid 30 dB SNR between his office and the mesh AP, and a high SNR between the 2 mesh APs. So he was able to get good performance. So what about this? This looks kind of crazy, but I'll tell you, this is very common, actually. This is actually a very common scenario where there are too many access points, too many mesh nodes in a very small home. And the idea here is that you're blanketing the home with lots and lots of RF signal. There's no place that you can go in this house where you don't have 30 to 35 dB SNR, 35 dB SNR anywhere in this house. I shouldn't say that because I don't even know what the noise floor is in this house. I will say there's nowhere in this house you can go that you don't have neg 66 dB SNR or better, Actually, that's neg 66 at 5 gigahertz. You can, in this house, you can actually get below neg 60 at 2.4 gigahertz. Now, let's get into a real world example. This really happened. This whole picture really happened. So about 2 months ago, I got a phone call from a friend. He says, I got a friend of mine, so a friend of a friend. And he asked me, can you, on a Saturday, he says, can you call this guy up and help him with his Wi-Fi in his house? He's having problems with Zoom. So I called him up and said, what's going on? He said, well, Zoom, he's a minister, a local minister, and he has to give a talk on Sunday morning. He has to give a public talk. And all that week, he's been trying to improve the Zoom quality in his house. And the quality is bad. Everyone tells him the quality is terrible. In fact, I was on a Zoom call with him, and I can tell you it was horrible. His video would freeze up, the audio would drop out, and there's no way he could do his public talk on Sunday with that kind of quality issue. So what do you do? What do you do? So first we installed TeamViewer so that I could log into his laptop remotely, and I installed just an average Wi-Fi analyzer program, you know, online, just something basic, something that would be able to show me the SSIDs, the average RSSI bands and channels, things like that. So now we take a look at this. Now I covered up the MAC addresses with these words mesh and my SSID so you can't tell who it is that way. So I've covered those up. But other than that, this data is directly from this network. There were 6 devices on 5 gigahertz with signal greater than neg 69. You notice there, start at the top, Xfinity Wi-Fi, neg 66, neg 66, mesh, neg 65. Scroll down your eyes down to my SSID has the weakest signal at neg 69. So there were 6 devices using an 80 megahertz wide channel, in the 5 gigahertz band, including those mesh nodes. Now, mesh SSIDs are not broadcast, right? So they don't show up on the laptop, but the scanning software picks it up. And even though it doesn't show up as an SSID, it is an SSID, and it is a source of interference in the network. So this network had very high CTS, RTS, clear to send and request to send packets. It had high packet retry rates, had high latency, and so the Zoom quality was bad. So what do you do to fix this? If you're looking at this network, what's your first thing you're going to do? Think about that for just a minute. I'll tell you what the first thing we did is. First thing we did is we unplugged all the mesh devices. You probably said that already yourself. Unplug all the mesh devices, and I think you probably would have done that. So that's the first thing we did, and then we measured his signal off of just his one access point, and indeed it was it was not a good signal strength. So then we added back one mesh device, and we positioned it, like I told you in the previous example, about 50% into his house, a little bit more than 50%, and that fixed his problem. And that ended up fixing the problem. Now, the next thing we did is we reduced the channel width from 80 megahertz down to 40 megahertz. There's no reason to use 80 megahertz. In this case, this particular service provider, you can tell who it is by the name there, they like to configure everything by default to 80 megahertz and don't tell people the benefits of changing it. Why do they like 80 megahertz? Is it better? Is it faster? No, not really. If anything, 80 megahertz is a problem because it uses 4 channels concurrently, and it adds to the signal noise across 4 channels. If multiple neighbors in your house, or if your neighbors next door are using 80 and you're using 80, you're consuming too much channel utilization and you're not getting any benefit out of it. So reducing the channel width also improved the quality of the link and reduced the retry rates and reduced the latency. That's how we fixed this problem. So folks, I'm going to pause for just a moment, and I'm going to pop up the first poll that was supposed to pop up a couple slides ago. So if you can do me a favor, I'm going to launch this poll. So the question on this poll is, what percentage of your customers prefer to buy a managed Wi-Fi service? So if you are back in the very beginning here, we talked about delivering broadband to the home. We talked about delivering broadband through the home and being able to sell a managed service. So, let me know what your thoughts are on that, because this is important for you to understand also what your potential is in your business, right? There's potential to make money for you here. So this is a good poll, actually. A little better than I thought it was going to be. I like this poll. I like this a lot. You guys are still voting. That's great. I'll go ahead and stop the poll right now. I think that's pretty close. That's pretty statistically accurate. 56% said less than 50%. That means there's money to be made here. You can actually, let me get back to my slideshow here. There we go. So less than 50%. So most of you actually have less than 50% of your customers want to choose a managed Wi-Fi. So one of the things that you're going to find from Cambium over the next in 2021, we're going to be releasing not just products, but tools that will deliver a managed Wi-Fi service. And so as we do that, we will help you to be able to explain to your customers the benefits of this and actually show them the benefits of delivering a managed Wi-Fi service. And that's something that will be really important for you to build out your business and generate more revenue and have a happier customer. So the first thing that you'll see that's going to be a big benefit is Wi-Fi 6 in residential Wi-Fi. Now, why Wi-Fi 6? And usually we think of Wi-Fi 6 in terms of devices that connect to it, right? The latest iPhone 12 has Wi-Fi 6. You might be thinking about that. The Samsung S10 has had Wi-Fi 6 now for, whenever it was released. I forgot when it was released, 2019, I think. A long time ago, right? So we have devices out there. Intel chipsets, the latest laptops have Wi-Fi 6. They've been out there for a year. Intel radios have been out there for a year, and Intel tends to have, they tend to build really good Wi-Fi radios with low latency. So they're out there. We tend to think of Wi-Fi 6 for the client connectivity, but think about it for the mesh. With Wi-Fi 6, that the mesh itself is going to be a minimum of 25% faster. Minimum 25% faster. That's on day one. Even before the technology is fully utilized and leverageable, 25% faster than previous generation, than 802.11 AC. It has better radio sensitivity, and this has been proven over and over again in testing. The radio sensitivity of Wi-Fi 6 is better than 802.11 AC. That means you're going to get the next up MCS rate. That's going to add 10%, 15% to your throughput right there as well. With the same link signal, you're going to get a new NCS rate, a faster NCS rate. Over time, as the client devices adopt more 11AX, this mesh link will also get faster because of the time that it has to use the new protocol instead of sharing time with the older protocols. And finally, it helps us to eliminate the need for tri-radio 11AC mesh nodes. And these tri-radio 11AC mesh nodes really sound like a great idea, but they cost more money, and they end up using more 5 gigahertz channel width than you need to be using. You don't need to be adding more channel width to your home to deliver a high quality mesh link. So Wi-Fi 6 allows us to reuse that same frequency. And then it's going to get better. It's going to get better. And Wi-Fi 6 standard supports bidirectional transmission. That means both directions, upstream and downstream. This is brand new for Wi-Fi 6. Multi-user MIMO will be very appropriate for mesh links. That allows those mesh devices to talk to each other using MU-MIMO to increase the bidirectional performance. Over time, reduce latency. Again with the protocol. As you start to connect more devices through the mesh and then to the client device, the longer OFDM symbols, BSS coloring, the spatial reuse, upstream power accumulation, improves the connectivity, improves the SNR, Overall, Wi-Fi 6 has reduced latency versus 802.11ac. So the effective throughput is going to be in the range of 750 to about 1.2 gigabits per second. And it could be higher when you start adding up the bidirectional capabilities. If you add both directions, it'll be even higher than the 1.2 gigabits per second. So Wi-Fi 6 is the ideal technology to build a residential mesh network that supports high density. But that's not all. That's just hardware. That's just a hardware solution. There's more things required. So in addition to Wi-Fi 6, we also need to have better management. Of course, what Cambium will do in 2021 is connect these devices to our CN Maestro cloud. CN Maestro cloud, you can operate from the cloud, from on-premises VM, from AMI. Additionally, we're going to give you a consumer management app. So removing the requirement now to log into a web page to find out how to configure the device, your customers will be able to do the things that they do just with a simple to use app. We're going to add network assurance software to the AP and to the network. So the network itself will become more intelligent, more able by itself, without your interaction, to adjust to sources of interference. To find those sources of interference, whether it's the fixed wireless broadband that's using 5 gigahertz channels outside the home, or neighbor devices or client devices inside the home, being able to mitigate those interference, find a cleaner channel with lower channel utilization to improve the quality of the link. Improve roaming, the ability of devices to connect to the best access point, automatic mesh, self-healing mesh that tailors itself automatically to the home environment. So it'll be a little bit different in one home versus another home because the environment has changed. So this network assurance software will be added to the access points, making the network itself more intelligent. On CN Maestro in the cloud, CN Maestro on premises, technical support analytics, using those network KPIs to give you a more proactive diagnostics. So you can identify problems before the customer calls and create an action plan that can be effective before they call and complain. And remember, when they're complaining, oftentimes it's about latency with the application layer that they're using. And the consumer management app, that's going to be a key thing because that's going to also help us reduce trouble tickets. Let me pop up another quick poll. I only had 2 polls. Let me pop up the second poll here. And I want to see what you think about these 3 areas that I just talked about. So, you look at these 3 things I just described to you, which features here do you think is going to best support your management strategy? What's going to have the most benefit in your networks as you start to think about, if I roll out a managed Wi-Fi service, I'm potentially exposing my company to more risk. How do I manage that risk? How do I manage the risk? Because I want to make more revenue, I want to have happier customers, I want to reduce the churn rate, the amount of people leaving the service. But when I do that, what's the best tool? Is it going to be network assurance software running in the network? Is it going to be more technical support analytics to help you be proactive and reactive? Or is it going to be putting more power into the hands of your customer? Which one of those 3 is going to help you the most? So think about that. It's a good question, isn't it? We're going to deliver something in each one of those categories. We are going to be delivering each one of those 3 categories. And I'd certainly like to see what you think will be the most effective. Okay, let's go ahead and stop that now. That's a good, I'm glad to see the results of that. Right about 50% of the people actually said that they would probably get the most benefit out of the cloud-based technical support analytics. So I like that. That's a good response. And fortunately, CN Maestro is very well placed to do exactly that. It sits the right place in the network. The nice thing, CN Maestro is in the cloud. Cloud never sleeps. If you've heard my webinars, you've heard me say that many, many times. I like that phrase. Cloud never sleeps, even when we do. It's always on, always available. So it's a good place to put it. The benefits to service providers, particularly with this proactive issue resolution, these troubleshooting diagnostics, is lowers your help desk tickets. Statistically, 30 to 50% would be a good target. 30 to 50% lower help desk trouble calls. Reduce on-site truck rolls. Again, 30 to 40% is an industry statistic here that can be done. And of course, generate recurring revenue. Use RESTful APIs from Cambium to integrate with your own management systems and your own operation software. Benefits to the consumer. People like to know what's going on. They like to know. They don't like to be in the dark. And you know, our customers are pretty savvy these days. People are working from home. They're going to school from home. If you give a little bit of tools, give a little bit of something in their hand, help them to understand what's going on in their network, they can really become a really important part of your ability to deliver a managed service, because they will have the tools in the consumer app to answer the top questions. So tomorrow, Thursday, at 2 p.m., there's going to be a fireside chat with CTI Connect. They're calling it the 12 Days of Wireless. They're hosted by CTI. I was talking to them yesterday on the phone about this, and they were reviewing with us the different things that they're going to be offering for prizes. They got a ton of prizes. They have an electric scooter. They've got smartwatches, drones, home audio systems. They've got a bunch of stuff. So if you like free stuff and you like to get good stuff, then and you want to hear some good information from Cambium, come tomorrow. Sign up for this CTI Connect fireside chat. You can email them. They'll send you a link back to register, or you can check their Facebook page. That's also a good choice. And you can see the link to register right there on their Facebook page as well. So tomorrow we will also be talking about, I'll be on that chat as well. I had 2 slots on that chat myself. One of them is to give you an overview of Wi-Fi and changes coming in 2021. And this topic about what we are doing in residential home Wi-Fi will be brought up again tomorrow afternoon. Additionally, I have another spot a little bit later in the program about CN Maestro. And CN Maestro isn't really it's not my PLM responsibility, but really, quite frankly, CN Maestro is everybody's PLM responsibility at Cambium. We all take CN Maestro very seriously and understand that the benefits of that cloud-based platform to deliver the right analytics that you need to do your business. So I'm glad to be able to share information about CN Maestro coming in 2021. So hey, the new year's coming, folks. It's just a couple weeks away. So I thank you both folks for coming. We shared today some common problems that occur in the network. We shared some of the challenges that you see with density as your customers add more devices into their homes. And I gave you just a little bit, not a lot. And I know it was not a lot. I know that wasn't. I gave you a little bit of what Cambium's thinking is on the matter and what we are planning to do. We have been very deliberate and careful about making sure that when we release this managed residential Wi-Fi platform, that we do so with the right technology. And we firmly believe that Wi-Fi 6 is the right technology to deliver this high quality managed Wi-Fi service that's going to build your business. So I thank you folks for joining us today. And I think we have plenty of time left over. We went about 40 minutes. So if you have any questions, please let me know. And if not, that's okay too. I know I probably left you with lots of things in your mind. You're going to think about them tomorrow, and you're going to wonder, oh, I should have asked him something or other. But please let me know. So one of the questions is are you talking about the XV2 product in Wi-Fi 6? And no, the answer is no, I am not talking about the XV2 product. Let's see if I can get my question pane to show up here. It's not really showing up very well. And let me see if I can make it bigger. Yeah, that's better. Here we go. Okay, So another question is how does the longer symbol time help with outdoor Wi-Fi? Yeah, it absolutely does. So the longer symbol time, it also goes with a longer guard interval. And particularly in the outdoor space, it's the guard interval that's going to really help you with the outdoor Wi-Fi. So you're going to get a little bit more time between each symbol, and that's going to give you more resiliency in outdoor networks. It gives you a little more resiliency to interference. Now that also in the outdoor space, Mohammed, in Wi-Fi 6, they duplicate the payload. The payload that goes with the packet is duplicated in that longer symbol. So if part of that frame is destroyed due to interference, it's more likely that you're going to be able to recover all the missing data because you've actually duplicated the payload. Another thing for outdoor is adding 3 dBi, doubling the power of the preamble. So the preamble portion of the packet is going to have a 3 dBi boost for outdoor Wi-Fi, and that's going to give you more resiliency and range. And the key there really is the resiliency part, right? You want to make sure that you get the packets to the device with a high quality and high resolution. So when Cambium starts shipping Wi-Fi, when will Cambium start shipping Wi-Fi 6 routers? I can't say that today. I'm not allowed to give you the date today. So Kevin, keep in touch with us. We will be announcing dates soon, and we do have the Wi-Fi 6 products in the enterprise space, the XB2, the XB3, and then tomorrow on the CTI Connect call, we'll be talking about some more things happening in 2021. When will XMS Cloud get full support for XB2 and XB3? So XMS Cloud should support those as of day one. So if there is a particular issue, please send it through our customer support team. We do meet with customer support to look at issues. I do know that there's been a lot of questions about some of the features from XMS Cloud being implemented in the XB2 and XB3, and those are being rolled out in time. So that if there's a particular feature that we have not yet implemented, please let us know. You could even put it in the chat if you wanted to, and that'd be okay also. But yeah, I'd like to know that. So I do know that we launched the XB2 and XB3 in early 2020, and it did launch on XMS Cloud. And then actually XMS Cloud came about 3 weeks before CN Maestro did. That was early in the year. We're going to get more information on Cambium CBRS products. And well, you can go to cambiumnetworks.com. Also, Olivia, we should also advertise, Olivia, where the folks can see our past webinars on the topic of CBRS. So Mohammed, my coworker and compadre, Matt Mangriotis, manages the CBRS products, and he actually delivered some really good webinars on this. He turned out to be an outstanding head-to-head webinar versus one of our competitors. I think it was just a few weeks ago. It was with CTI Connect, and it was with a competitor, and they were talking about these exact topics. All of that should be on the Cambium Networks YouTube channel. So go to the Cambium Networks YouTube channel, type in CBRS. You should be able to see that video that they just posted from Matt. It was an excellent webinar. He is an absolute subject matter expert when it comes to CBRS, all those fixed wireless solutions. He's been doing it a lot of years, and he's just a great guy for us to have at the company, and he puts out some very high quality webinars. So check the Cambium YouTube channel. Olivia, if you have any other ideas on that, just drop it in the chat as far as where he would go to get that. Last, so thank you for pointing out the XMS Cloud. I'll take a look at that. Last, just let me know which of those you're particularly concerned about, which features, and I can talk to engineering about their priorities and where they're at delivering those. So with the latest Android and iOS mobile phones, yeah, dynamic MAC address. That's interesting. Dennis, I haven't heard of that problem. So you're wondering if the dynamic MACs on Android and iOS causes impersonation attacks, station impersonation attacks. I'll have to look into that, Dennis. I don't know. I do not know. It certainly impacts, the dynamic MAC address impacts location-based services. And I was at Motorola, 8 years ago, 2012, when we were launching the first location-based services using Wi-Fi and Bluetooth low energy, and we were pretty advanced. Actually, we had done it in 2010 through the air defense product at Motorola. We did some location-based things in 2010, but really it was 2012 that we really started to push out lots of that technology in retail. And then it's kind of died off, right? These dynamic MAC addresses have really made it hard to identify individual users. But what's happened is really the industry has shifted to better use anonymous data. So we still can create location-based value for the service providers, but without having to know exactly who's connecting. And by the way, that particular issue right there will be addressed by our managed home Wi-Fi service. At least it's part of it. It's part of the solution that we're delivering in 2021 for managed home Wi-Fi. So again, I thank you folks for joining and some good questions. I could answer most of them. I could not answer the question last asked about particular features missing from XMS Cloud, so we'll find out about that. And I could not answer the question about station impersonation attacks in Xero's products, and I'll find out about that, Dennis. So thank you, folks, for your questions, and I have some things to do myself, some research and some research to do to answer your questions. So thank you for joining, and I hope to see you folks tomorrow. And we will be talking again later in 2021, sharing more information on timelines and deliverables with this new managed residential Wi-Fi product from Cambium Networks. All right, cheers, folks.